Hello everyone, welcome to our training session on what's new in SV Switchboards. My name is George Roscoe and I'm the product manager of Switchboards. This training will take you through our latest product launches and the new features they provide. One of the biggest design changes to Switchboards has come about due to the National Electric Code Clause 240.87. This new code requires any circuit breaker with a 1200 amp frame or higher to have some level of arc flash energy reduction by reducing the clearing time. There are 7 proposed methods to reduce the clearing time. The first is zone selective interlocking, which is a communication system between upstream breakers and downstream breakers that allow the breaker closest to the fault to trip first. The second is differential relaying, which is a medium voltage relaying technique that, like zone selective interlocking, has the breaker closest to the fault trip. The next is energy reducing maintenance switch with local status indicator. This is an alternate set of trip parameters or an alternate instantaneous level that when switched on is activated inside the breaker. In Siemens we call this DAS or dynamic arc sentry. The fourth is an active arc flash mitigation system. Think of this as an arc flash relay or some type of crowbarring system that will actually create a voltage fault to put out the arcing fault. The fifth, which is a new clause for NEC 2017, is an instantaneous trip setting that is less than the available arcing current. The sixth, which is also a 2017 edition, is an instantaneous trip override that is less than the available arcing current. What this means is if you can set the typical nominal trip setting below the arcing current, that is now an approved means for NEC 2017. And number 7 is an approved equivalent means, which is basically up to the discretion of the inspector. By far the most common is the energy reducing maintenance switch with local status indicator. In 2015, Siemens' solution to the maintenance mode switch was only available in the WL. We heard the competition could use multi-case circuit breakers, and this put us at a competitive disadvantage. Last year we launched the Smart DAS solution, which allows us to integrate VL breakers into the maintenance mode family. This solution can be used on switchgear, switchboards, and P4 and P5 panel boards. It's available Compass now as a standard. The Smart DAS system starts with circuit breakers needing maintenance mode tied together on a Modbus RTU network. This includes VL and WL circuit breakers. This network is connected to a Modbus RTU to Modbus TCP IP converter. This converts the Modbus data to Ethernet. Once converted to Ethernet, it is connected to a controller. The controller is connected to an activation switch, which is assigned to one of the breakers needing maintenance mode. When the switch is turned on, the controller switches the circuit breaker assigned to the switch into maintenance mode. Once the controller verifies maintenance mode has taken place, the blue indicator light will be turned on. There's a couple other options for activation. The second is a master switch that is for the whole system and one indicating light per breaker. This puts every breaker in maintenance mode once the activation switch is flipped. The second is an HMI, which is an optional way to turn it on as well. Instead of turning the maintenance mode on by a switch, it's done on an HMI. The HMI will also include the ability to change the VL settings right on the HMI instead of over a Modbus communication controller. Smart DAS is available in switchgear, switchboards, P4 and P5 panel boards. The system will easily fit in a full-size aux compartment or a 7.5-inch panel-mounted compartment. Key configuration notes are the WL breaker will need the 776 trip unit and Modbus communication. The VL breakers will need the 586 trip unit with Modbus communication. For the WL and VL settings for maintenance mode, they are defaulted to minimum. The VL settings are 1.25x out of the box for short time instantaneous. The settings can be changed on the controller for VL via Modbus, and the WL settings can be changed on the breaker. The required features for the VL circuit breaker with Smart DAS are mostly automatically selected when Smart DAS is selected on that breaker. The key features are the electronic trip unit with LCD display, which is the 586 trip unit, and the Modbus communication module. The one thing that needs to be considered when selecting Smart DAS on VL breakers is that a 24-volt DC power supply is required for one for every 7 VL circuit breakers in order to power them up. So this will need to be added if you had 14 circuit breakers with DAS, even if it's unlikely. They require 2 breakers to have the power supply option selected. For the WL circuit breaker, all features are automatically selected, but the key 2 features are the ETU776 and Modbus communication module. DAS is a standard option in Compass. Under the main option tab at the top of the tree, you will see where DAS is available. There is 2 options for DAS on the system. Standard DAS, which is only available for WLs and is recommended for single WL usage, is an SB2 feature, just recently moved from SB3 to SB2, that has license switches assigned for WLs. For Smart DAS, this is recommended for multiple WLs or anytime you need a VL. There's a couple ways to select DAS. You select it for mains, it'll only appear as an option for main circuit breakers. And then mains and branches, it'll be available as an option for all mains and branches that are DAS capable, which will be all WL/VLs. A couple of the options, as I mentioned earlier, are also here. The switches and lights, we have 1 switch and light per breaker. Single switch and light, which has a master switch for all breakers and a light per breaker. The HMI option, which allows you to turn them on via HMI. And one other design note is auxiliary compartments will be generated for each DAS device. You may remove them if necessary. A general rule of thumb is that you're going to be requiring 1 auxiliary compartment for the controller per 10 breakers, and then that can either be panel mounted or put in an existing full-size auxiliary compartment. General configuration notes. The DAS controller, as mentioned previously, requires to be placed in either a full-size auxiliary compartment or alone in a panel mount 7.5-inch compartment. One other thing to consider is that the communication modules will need to be in the same section as the breakers. This is the same rule as it has been previously with VL breakers. The lights and switches will be mounted on the communication module door, so it's important to make sure the lights and switches and the communication panels are mounted near the breakers you want to control. In this example, we have 2 compartments for 3 breakers, because one of these compartments also houses a 24-volt power supply, and the other one holds the other 2 Modbus controllers. And in the third section, since we already have 1 power supply for 7 breakers, that aux compartment has the COM modules and then the lights and switches for those 2 breakers. If you need any additional help with this, please contact your local application engineer or your local business developer. They can help you lay out the board appropriately. One of the key features of Smart DAS versus the competition is the ability to adjust the VL settings. Most molded case circuit breaker maintenance mode only allow instantaneous adjustment down to 2 to 4x, and it is hard-coded. Smart DAS allows its users to adjust the settings as needed. The settings that can be adjusted are instantaneous, short time, and the short time delay. The image on the left shows the normal mode of a 1200 amp circuit breaker, and during the arc flash study, the 2 dots show, it was found the arcing current was around 10,000 amps, meaning normal settings were above or at the arcing current, meaning the settings would need to be changed to comply with 2017 NEC 240.87. The right image shows the difference between Siemens' Smart DAS system and the competition. The competition is in blue, and they would have to hard code their settings to 2x, while Siemens with the Smart DAS system could set the instantaneous to 7x, be below the arcing current, but have better selectivity than the competition. Again, this analysis requires a certified professional engineer and an arc flash study, but it does display the flexibility of the Siemens Smart DAS system. For breakers equipped with Smart DAS, you're essentially internet ready. By either adding an Ethernet switch or a wireless router to your system, you can access data from your Smart DAS devices onto either your computer or your phone. What this could do is allow you to remotely view statuses outside the arc flash zone. It can allow for ease of commissioning. Using the Siemens Power Config, you can actually adjust the settings on your laptop and download them to the devices over Modbus. There are some third-party apps that also allow you to open and close your breakers outside the arc flash zone. All these features allow you to know the status of your system before activating maintenance mode. When using wireless, we recommend following enable WPA2 security, and use the latest and greatest wireless routers. These are just an example of some of the features that are adders when you select Smart DAS. So consider that when you're selecting Smart DAS, what else you may want to use it for, because there's some serious upsell ability here. One of the most recent product launches is Smart Gear, namely Smart Switchboards. Smart Switchboards take all the intelligent embedded devices in your gear and put them into one common HMI interface. Some of the smart devices can include low voltage power circuit breakers, power meters, multi-case circuit breakers, branch circuit monitoring systems such as SEM3, and they put them through an industrial personal computer, and through this it connects to an HMI, which allows all your devices to be accessed by one singular panel. Some of the key benefits of Smart Gear is it keeps your intelligence in the device, but allows you to access your data remote. The HMI can be placed on a wall outside the arc flash zone, up to 1,000+ feet away by using optical fiber. It also reduces the wiring for increased productivity. All the communication wiring is done up front, and the only wire you need to run is between the HMI and the IPC stored in the gear, increasing your speed of commission and startup. One of the other great features is all the settings can be adjusted through the HMI, maintenance mode can be turned on through the HMI, and the open and close can be done over the HMI, reducing the amount of time you need to now go in front of the gear. We like to call Smart Gear one of the most configurable self-mounting apparatus on the market. It's easy to design, easy to specify, easy to commission, easy to operate. One of the newest products launched is the Siemens Skinny Main and Branch WL design. It's the narrowest single-mounted power circuit breaker in the industry. This design includes up to 2,500 amp fixed WL circuit breakers. It reduces the footprint by more than 12 inches. The original size was 38 inches, it's now 25 inches. This design also includes the hinged auxiliary panel that allows better lug access and splice plates for accessories. It integrates in any standard SP lineup and is now orderable through Compass. Here is a side-by-side comparison of a main WL section 2,000 amps from the old 38-inch design to the 25-inch design. You can see here you still have some of the same great features such as surge protected devices, meters, maintenance mode, just all in a more compact frame. You can save space by 30%. The key enabler of this narrower design is the hinged auxiliary compartment. As you can see step by step walking through the design here, the compartment first hinges open for access to the components in the auxiliary compartment, and then can hinge out of the way completely for access to the lugs and splice plates. Another great feature is that there is up to 2 auxiliary compartments per section, which allows for more square footage than the existing standard 38-inch wide design. Also with these hinging, you get better access to the rear than the existing design has, even though it is wider. Because of the hinged aux compartment and 180-degree hinging, for outdoor applications we recommend rear access during install because the hinged auxiliary compartment can only pivot 90 degrees. In summary, a lot of the great key features of the Skinny Main are the same as its original counterpart. It's available in NEMA 1. NEMA 3R is available with rear or side access during installation. Copper and aluminum bus are available. It can go up to 100 kA maximum. It's seismic rated CBC IBC. There is no OSHPOT certification for this design. It's available with surge protective devices, maintenance mode, and pack meter. Easily all fit in one compartment. And there's additional room in the secondary auxiliary compartment for non-customer facing devices. The 4-high design is another one of our recent launches. It fits up to 4 2,000 amp drought circuit breakers in a single section. That section is 32 inches wide, and next to is a variable width wireway from 20 to 46 inches wide. The wireway is dependent on the number of cables per breaker and the direction of the cables. So mixing an optimal amount of cables at the top and bottom will reduce the width the most effectively. The section bus can be up to 4,000 amps, which in reality means that I don't think there'd ever be an application with 2,000 amps. The design is also rated up to 100 kA and is seismic rated and can be integrated to any existing switchboard lineup. There is no OSHPOT on this either. Some of the benefits are it's all front connected, reduced floor space, It's the highest WL breaker density we have in front connected switchboards. And by doing this, everything is considered front access, therefore now you can place lineups back to back. As more and more designs migrate from switchgear to switchboards, the 4-high design is a big enabler to help do that. This example here shows the difference from using rear connected switchgear versus the front connected switchboard using the 4-high design. If the customer required 4 draw-out circuit breakers but was willing to accept the switchboard design, we could save them space. Here's how. If some breakers could be group mounted, that takes away 2 sections. Then if the other 4-high need to be connected with draw-out circuit breakers, those can go in a 64-inch wide section. So that's a 32-inch wide breaker section with a 32-inch wide pull, and then the main breaker will go in a 38-inch wide section on its own. By doing this, we save the rear access space because switchboards are front accessible, and then we also save on the equipment space. So the equipment space savings is about 20%. The rear access saves about another 10%. So overall, we're saving 30% of equipment space and floor space, making it a very attractive option for a customer who has floor space and equipment space restrictions. These slides show an example of the 4-high design in actual production. The breakers are on the left and the pull section to the right. In addition, the right picture shows the lugs and how they're located. They are located facing the user at the front of the gear, and this section was optimized to have some lugs go at the bottom and top. And one other tip of the trade is the best way to optimize is have slightly more lugs going out the direction opposite of the through bus, because the through bus will restrict your conduit space on whatever side it is on. Finally, 2 years ago, SEM3 was introduced. SEM3 is an extremely popular out-of-the-box modular metering solution. The images show the 2 main applications. The one on the left is a very common application where 2-pole loads feed an apartment. Application 2 on the right is metering for larger loads such as a facility or data center. The metering gives them some lead points. SEM3 is fully integrated into panel boards and switchboards and can monitor any circuit breaker from 15 amps all the way up to 1200 amps. It communicates over Modbus TCP/IP and recently communicates now with BACnet. For more information, visit the Siemens webpage, but know this is fully integrated into switchboards and it's a great option for sub-billing and energy monitoring applications. To conclude, several new features have been launched in the last few years to help optimize footprint and save space. We have the latest technology to allow us to comply with code requirements such as 240.87, and we're incorporating technology into our devices more now than ever, including SEM3, Smart Gear, the ability to connect Smart DAS systems to laptops, mobile devices. This is ever increasing, and we wanted to let you know that Siemens were at the forefront of it. Thanks for your time today. Feel free, if you have any questions, to reach out to your local Siemens sales rep, and have a wonderful day.